So whenever you're dealing with data, you have to be constantly aware of how your audience is going to see the data. How are they going to engage with that data? Will they be able to access the information that you're trying to get them to access? And whenever we're creating any kind of a data visual, we need to be very aware of how we are representing that data. Are we taking things out of context? Does this ethically and accurately represent what's actually going on? Or has it been skewed? Has it been manipulated? So we're going to take a look at a few slides of bad examples of data visuals, and we're going to explore some of the ideas and some of the strategies that have gone into making those ineffective or unethical in some way. So let's start with this one. Now I'm not going to pick just on Fox News, although Fox News has a wealth of examples. I will also pick a little bit on MSNBC a little bit later. But let's start by just taking a look at this picture. If the Bush tax cuts expire, 35% is what you're paying now, 39% is the top tax rate that you would pay under that. So, what's wrong with the example? What's wrong with the representation here? You can hit pause if you want to take a few moments to kind of digest it, and then just hit play when you're ready. Do you see what's going on? Let me point it out for you. First of all, in this data visual, you have 39% here, 39.6%. That's the top margin, the top tax rate that you would be charged if the Bush tax cuts were to expire, and then 35%. That's the tax rate that you pay now with the Bush tax cuts in place. What's odd is that this 35% looks like it's about a quarter of the 39%. This is not accurately representing the difference that exists between the 39.6% and the 35%. What they have done is they have decided not to zero out the y-axis, and when you're dealing with any range of numbers, you have to zero out those numbers to start with. Otherwise, by not zeroing out, you're basically putting it under a microscope. So think about this. If you're not taking into consideration the context of 0 through 33%, then it exaggerates the difference that exists between the 34 and 39.6%. So how would we go about fixing this? What would be a more ethical representation of the data? Well, it would actually be something like this. You can see here that there is a difference. This is definitely lower than this tax rate, but the increase isn't that huge increase that's represented in the other graph. This increase is pretty small. It's more in context. It's actually fully in context because you take into consideration 0 to 100%. That's the full range that you can use. So this is completely as in context as this can appear. And so you can see that the amount that it's raising isn't that much. So this would be a more accurate and a more ethical representation of what you're trying to communicate. Yes, it does increase, but the increase is not as pronounced as it is in the prior graph. So let's take a look at another example. What's wrong with this picture? Again, like I said, Fox News has a lot of good examples, so I'm using this one. But take a look at it. What's wrong with it? Again, you can hit pause if you need more time, but if you're ready, let's go on. If you think you have it, let me just point one thing out. This. If you take a look at the percent rates, first of all, you're not zeroing out the y-axis again. So again, you're zooming in to try to create this pronounced difference. But at the same time, you have to keep in mind when you're placing items on a graph, you want to make sure that the numbers that you're inserting correspond with the placement on the graph, where the placement on the graph should be. So if you take a look at 8.8%, that's the one at the lowest point on the graph, but the lowest number is 8.6% here, and 8.6% here is even with 9% here. So what you end up having is a graph that does not have a standard distribution of the data points. There's something wrong when 8.8% appears below 8.6%, and that is just sort of irresponsible. That's really what it comes down to. It's irresponsible treatment of the data. Now, if we decided to place this stuff more ethically, what we can also see is that there's another problem with the whole zeroing out. Even if we placed all of the data sets ethically, within the designated spaces, we would end up with what MSNBC has. MSNBC is working with the same data range, that starts at 8%, goes up to like 9.2%. And here, again, they're not zeroing out the axis, and this is what happens when you don't zero out the axis. You zoom in on a certain segment of data, and this is what it looks like. It looks like the percent of unemployment is almost down to 0. It's not. This starts at 8%. That's why it is down here. When you only deal with a very slim area within your graph, if you're only dealing with a very slim range, it does pronounce those differences. It's the same thing that happened in the first example. Not zeroing out the graph allows you to zoom in, and it shows you an exaggerated difference that really isn't existing. Now, if you wanted to look at this unemployment rate completely within context, this is what it would look like. There is a little fluctuation. You can see a little bit of a curve, but generally speaking, in the time period that we're looking at, not much changes. The unemployment rate stays just below 10% and kind of lingers there for the entire year in question of 2011. So really, neither side is accurately or ethically representing what's going on. Now, you would see if I decided to reduce this range and say I only went to 50%, this graph would change slightly. There would be slightly pronounced differences from one month to the next, and it would skew the information. It would give it a different visual representation. Still, it would still be fairly within context. You still wouldn't see a huge spike in unemployment rates like you would see here, or in this one where nothing happens. But totally within context, you kind of see the unemployment rate staying relatively the same. It's not changing that much. What's wrong with this picture? This one's a little different, but for the most part, it can be summed up as it doesn't have a title. Without a title, we don't know what this green represents. We have a key. We can say, okay, this is representing different percentage ranges, but I don't know what all of the percentages are for. I don't know what we're looking at exactly. When you add a title, Diagnosis of ADHD in Children, K through 12, this becomes a little bit more apparent. You can kind of see where are instances of ADHD more apparent in the United States. And you can see diagnoses from the West Coast to the East Coast, and you can see the progressive rise of ADHD diagnoses as you move east across the country. So that's basically what you're looking at. You add a title there, and all of a sudden, now I know what I'm looking at. So what can we do to really make effective data visuals? Well, you can kind of sum it up with these basic criteria. You need to have a title so that I know what I'm looking at. You have to have a key or a legend in cases like this, where you have a gradient or a color that's representing a different percentage point. You need to make sure that you have a legend so I see what that different color represents. X and Y axes must be labeled. That refers to, on a line graph or a bar graph, you would need to have the y-axis, which is y to the sky here, and then the x-axis that goes along the bottom. I need to have labels. I need to know if these are numbers. I need to know if these are dates. I need to know what those data points represent. So x and y axes have to have some labels. In addition to these labels, you also have to have titles, so that I know exactly percent of unemployment. Oh, and now these numbers now have a complete meaning. Months in 2011. Well, I know they're months, but now that you say 2011, I know the context. So the vertical axis. If you are dealing with numbers in your vertical axis, you have to have it start with 0. Always have it zeroed out. 0 is probably the most important number in arithmetic because it puts everything into context.